In 1943, a single American shipyard launched a 10,000-ton cargo vessel in 4 days and 15 hours. Across the Atlantic, German craftsmen took 6 months to build one U-boat. The outcome of the Second World War wasn't decided by generals or tactics. It was settled in the factories, where one nation had learned to make war faster than anyone could wage it. What happens when a continent of warriors meets a country of factory workers? For 1,000 years, European warfare evolved through craftsmanship. Knights forged armor plate by plate. Gunsmiths hand-fitted musket locks. Shipwrights shaped oak hulls timber by timber. War was an art passed master to apprentice, where quality mattered more than quantity. Then America entered the 20th century with a different idea. Henry Ford didn't invent the assembly line, but he perfected it, making cars so cheap that factory workers could buy them. When Europe tore itself apart in 2 world wars, the United States applied that same ruthless efficiency to tanks, ships, planes, and bullets. The result reshaped global power in a single generation. When America joined World War I in April 1917, the U.S. Army ranked 17th in size globally, smaller than Portugal's. European powers had spent 3 years grinding each other down in trenches, burning through artillery shells faster than artisans could produce them. Lower third. Shell crisis of 1915. Britain nearly lost the war from ammunition shortage. American industrialists saw a logistics problem, not a military one. Within 18 months, the United States shipped 2 million soldiers overseas and produced more artillery shells per month than Britain and France combined. The method was simple: break every task into repeatable steps, hire unskilled workers, and let the system create speed. But the war ended before America's full industrial weight arrived. The real test came 2 decades later. In September 1939, Germany invaded Poland with 2,800 tanks and air superiority built by precision engineers. Britain and France mobilized armies trained in the previous war's tactics. The United States watched from across an ocean, technically neutral, but already calculating production curves. President Roosevelt told Congress in May 1940 that America needed to build 50,000 aircraft. Military experts called it impossible. Boeing and Douglas were building planes one at a time, each requiring thousands of man-hours. Ford's Willow Run plant proved them wrong. Ford broke ground on the Willow Run bomber plant in April 1941, 8 months before Pearl Harbor source, Ford Motor Company Historical Archives. The building stretched over 3 million square feet, one continuous assembly line that could swallow the U.S. Capitol. Engineers divided the B-24 Liberator bomber into 5 major subassemblies that moved on tracks. At peak production in 1944, Willow Run delivered one complete 4-engine bomber every 63 minutes. Workers with 6 weeks of training installed fuel lines and electrical systems that European craftsmen needed years to master. The plant hired women, African Americans, and rural migrants, anyone who could follow standardized procedures. Quality came from the process, not the person. By war's end, American factories had built 18,500 B-24s. Germany's most produced bomber, the Heinkel He-111, reached 7,300 units over 6 years. The math was brutal. America could replace losses faster than enemies could inflict them. German Panther and Tiger tanks were engineering marvels: thicker armor, more powerful guns, superior optics. A single Tiger took 300,000 man-hours to build. America's M4 Sherman required 10,000 man-hours. The Sherman wasn't better. It was faster to make. U.S. factories produced 49,234 Sherman tanks between 1942 and 1945. Germany built 6,000 Panthers and 1,347 Tigers in the same period. American commanders accepted a 5-to-1 loss ratio because they could deliver 15-to-1 production advantage. The strategy was coldly mathematical. Every German tank destroyed was irreplaceable on the timeline that mattered. Every American tank lost could be replaced in a week. Britain entered World War II as the world's premier naval power, with shipyards that had built vessels for 3 centuries. Each ship was a custom project, taking 6 to 12 months. America's Maritime Commission saw cargo ships as floating boxes that needed to move fast from blueprint to ocean. Henry Kaiser, a highway contractor who'd never built a ship, won contracts to mass-produce Liberty ships. His Richmond, California yards prefabricated entire sections in assembly halls, then welded them together at the waterfront. The SS Robert E. Peary was assembled in 4 days, 15 hours, and 29 minutes in November 1942. That was a publicity stunt. Normal production took 42 days. But even 42 days shattered every existing record. By 1943, American shipyards launched 3 Liberty ships per day. Germany's U-boat fleet sank ships faster than Britain could replace them in 1940 and 1941. By 1943, American yards built cargo tonnage faster than submarines could sink it. The convoy system and radar mattered, but mass production decided the outcome. Between 1941 and 1945, American factories produced 300,000 aircraft, 88,000 tanks, 2,500 naval vessels, 6.5 million rifles, and 40 billion rounds of ammunition. The combined Axis powers, Germany, Japan, and Italy, produced less than half that total. The Soviet Union matched American tank production through different means, massive labor mobilization and simpler designs. But only America had the excess capacity to supply allies simultaneously. Britain flew American planes, drove American trucks, and wore boots made in American factories under Lend-Lease. Europe's military traditions, officer academies, regimental pride, artisan weapon-making became obsolete in a single war. The nation that learned to make identical Model T Fords had learned to make identical wars. The production statistics come from 3 primary sources. The U.S. War Production Board maintained daily tallies of every factory, published in quarterly reports, and a final comprehensive report in January 1946. The Strategic Bombing Survey teams cataloged Axis production by examining captured factories and documents immediately after Germany and Japan surrendered. Individual factory records provide ground-level verification. Ford's Willow Run kept time cards, production logs, and quality control reports now held by the Henry Ford Museum. Chrysler's tank arsenal in Detroit documented every M4 Sherman that rolled off its lines. These match government statistics within 2%. Contemporary reporting from journalists embedded in war plants appears in newspapers and magazines from 1942 to 1945. Life magazine published photo essays of women welding Liberty ship hulls. The Saturday Evening Post profiled Henry Kaiser's rapid shipbuilding. German production numbers required post-war reconstruction. Allied intelligence teams found Reich Ministry of Armaments files surprisingly intact in 1945. Albert Speer, Germany's armaments minister, testified extensively about production constraints during Nuremberg trials. His figures align with captured documents. One controversy persists around claimed production speeds. The 4-day Liberty ship was real but represented optimal conditions, not normal production. Regular Liberty ship production averaged 42 days in 1943, dropping to 30 days by 1944. Some historians argue that Soviet production and sacrifice, not American factories, defeated Germany. The USSR built 100,000 tanks and lost 27 million people. The Eastern Front consumed 75 to 80% of German military resources. This view holds that American production aided victory, but Soviet blood bought it. Others emphasize that raw numbers mask complexity. German tanks individually outperformed American ones. The Panther had better frontal armor and a more powerful gun than the Sherman. German engineers achieved sophisticated technology, jet aircraft, guided missiles, that the U.S. didn't match until after the war. This perspective questions whether crushing fairly describes a contest of philosophy more than capability. A third interpretation focuses on resources, not methods. America had geographic isolation, vast raw materials, and an intact industrial base. Germany fought a two-front war, while Allied bombing destroyed factories. Japan lacked oil and steel from 1942 onward. Perhaps America's advantage was circumstance, not assembly lines. Economic historians note that mass production worked because America invested heavily before entering combat. The 1940 to 1941 period saw $17 billion in factory construction. Britain and France couldn't afford the delay while already at war. The assembly line advantage required time and safety to establish. Finally, some analysts questioned the crushed framing. European powers remained militarily significant after 1945. Britain and France maintained overseas empires for decades. NATO relied on European ground forces during the Cold War. The shift was more about relative decline than absolute collapse. These debates matter because they change how we understand modern military power. Is production still decisive, or have precision weapons and technology changed the equation? The factory floor became a kind of front line. Workers at Willow Run pulled 12-hour shifts, 6 days a week, for years. Women welded bomber fuselages while worrying about husbands and sons overseas. Accidents happened. One worker fell into a wing assembly jig and wasn't found for 2 days. The production miracle had a human cost measured in exhaustion, injuries, and disrupted lives. For soldiers, mass production meant contradictory experiences. American infantrymen usually had more ammunition, better boots, and regular meals than opponents. But they also knew their Sherman tank would probably lose a direct fight with a German Panther. The psychological burden of numerical strategy, being the fifth tank that finally wins the engagement, rarely appears in statistics. This section discusses war production's broader human cost, without graphic detail. European civilians lived under strategic bombing that partly targeted war factories. The same industrial capacity that defeated Germany also destroyed German cities. Dresden, Hamburg, and dozens of smaller cities burned in raids meant to disrupt production. Whether area bombing was militarily necessary remains debated, but the connection between factory output and civilian suffering was direct. In occupied territories, people experienced the production war as shortages. Germany stripped factories from France, Belgium, and Czechoslovakia. By 1944, German civilians had no coffee, limited flour, and leather ration carts for shoes. The assembly line's success for one side meant deprivation for others. Military historians call this the birth of industrial warfare, where production capacity matters as much as battlefield tactics. Think of it like two chess players, but one gets to add extra pieces to the board every 3 turns. Superior strategy can't overcome overwhelming material advantage forever. The assembly line didn't just make things faster, it changed who could fight. Traditional European warfare required trained soldiers, skilled craftsmen, and experienced officers, all resources that took years to develop. American production needed 3 things: raw materials, electricity, and people who could learn simple tasks quickly. This is a modern parallel in software and automation. Companies like Amazon and Tesla use the same principle: standardize, subdivide, accelerate. The method Ford invented to make cars became the method America used to win wars, which became the method corporations used to dominate markets. But there's a deeper shift here. For centuries, European powers defined military strength through tradition and excellence. Prussia had the best-drilled infantry. Britain ruled the seas through seamanship passed down generations. France fielded the finest cavalry. These were cultures of warfare, not just armies. America approached war as an engineering problem with an acceptable solution timeframe. That mindset, practical, scalable, focused on results over honor, represented something new. Not necessarily better or worse, just fundamentally different. It's the difference between a master craftsman's sword and a stamped steel blade. One has soul and history. The other wins when you need 10,000 of them by Thursday. The implications extended past 1945. The Cold War became a production race: missiles, warheads, submarines. The Soviet Union tried to match American output and bankrupted itself. China studied American industrial mobilization and applied those lessons to civilian manufacturing. The assembly line method that defeated Germany became the template for modern superpower status. Here's what the evidence shows clearly. American factories outproduced the combined Axis powers by more than 2 to 1 in nearly every category of war material between 1941 and 1945. That advantage came from applying mass production techniques, already proven in civilian industry, to military manufacturing at a scale never before attempted. The numbers are documented in government archives, company records, and contemporary reporting. What's less clear is whether production alone decided the outcome, or if geography, resources, and timing mattered equally. We also don't know if European powers could have adopted similar methods given different circumstances. The historical record shows what happened, not necessarily what was inevitable. The bigger question is what this transformation meant beyond statistics. When mass production replaced craftsmanship as the basis for military power, something changed about how nations compete. That change still shapes our world. 3 scenarios help us think about modern implications, each with different confidence levels. Scenario 1. The pattern repeats, confidence, medium. Emerging technologies, drones, autonomous systems, cyber weapons, will favor whoever can produce and deploy them fastest. We're already seeing this in Ukraine, where both sides race to manufacture simple explosive drones using commercial components. The next major conflict might again come down to factory capacity, just making different weapons. Countries investing in automated manufacturing and supply chain resilience may gain advantages similar to America's World War II position. Scenario 2. Technology beats quantity, confidence, low to medium. Precision weapons, satellite targeting, and advanced defense systems could make mass production less decisive. One sophisticated missile defense system might counter thousands of conventional weapons. This would reverse the World War II lesson and return importance to quality over quantity. However, history suggests that countermeasures emerge for every defense, restarting the production race at a new technological level. Scenario 3. Production itself transforms, confidence high. Artificial intelligence, 3D printing, and automated factories are already changing manufacturing timeframes. What took 42 days in 1943 might take 4 days with modern methods, or 4 hours. This doesn't change the underlying principle that speed of production influences conflict outcomes. It accelerates the cycle. Nations developing autonomous manufacturing systems may gain the same relative advantage America had in 1943, but compressed into months or weeks instead of years. The most likely future combines elements of all 3. Technology will matter, but so will the ability to scale production quickly. The assembly line didn't crush European warfare permanently. It reset the rules for how industrial capacity translates to military power. The assembly line won World War II before the first shot landed perfectly, or the first tank found its target. What Henry Ford learned making cars, America applied to making victory itself. Not better, just faster and cheaper at an unstoppable scale. That principle hasn't disappeared. It's just waiting for the next conflict to prove it still works.